This lesson is about areas and areas of circles and sectors. Now we really have three different objectives here. One is to make sure that we know how to find the area of a circle. We need to also be able to find the area of a sector, which is kind of like a fractional part of the area of the whole circle. And then the last thing, which can be a little bit complicated, is what is called segments of circles. All right. So let's start off. Let's make sure that we understand how to find the area of a circle. I know that the area of a circle can be found by taking pi times the radius squared. Now again, sometimes they're going to ask us to leave the answer in terms of pi. Sometimes, and that just means pi is in the answer. Sometimes they're going to ask us to approximate the answer or round it. In that case, I'm either going to use the pi button on the calculator, or if they give me a specific decimal representation or fraction, 3.14, 22/7, I would use that. All right? The key is, in order to find the area of a circle, I have to know, from the circle, I have to know the radius. So let's take a look at these examples. In this first problem, they give me that the diameter is 11. If the diameter is 11, I know that the radius is 11/2, or I could write that as 5.5. All right? I'm going to go ahead and use 11/2. Now to find the area, I'm going to take pi times the radius, 11/2, squared. They want me to leave my answer in terms of pi, so I'm going to leave the pi alone. I just have to figure out what 11/2 squared is. That would be 121/4 pi, and then take my units, and because it's area, I'm going to have units squared. So the area of this circle is 121/4 pi centimeters squared. If I were to change that to a decimal, very simply, it's 121 divided by 4. I would say 30.25 pi. Nobody asked you to round. So I would say 30.25 pi centimeters squared. All right. In this next one here, they again give me a diameter. This diameter is 2/3. If I divide that by 2, I would get the radius is 2/6, which would simplify to 1/3. Okay, so I'm going to use that now and go to the area of the circle. I know that that is pi r squared. I have pi times 1/3 squared. All right, so I have an area of 1/9 pi inches squared. In this case, I would leave it as a fraction, because on the calculator, if I take 1 divided by 9, I'm going to get a repeating decimal. I can't put that decimal anywhere, so I'm just going to leave it in a fraction form. This is an exact value of the area. So as a word problem here, it says use an online store locator to search a store within a 5-mile radius. There's the key. You give me a 5-mile radius of your home. What is the area of your search region? I know that area is equal to pi r squared. So in this problem, I have pi times 5 squared, or an area of 25 pi miles squared. Now the problem is, how big is 25 pi miles squared? I don't know. So what I would do in this case is I would take 25 times pi. I didn't use any approximation they gave me. In the problem, they did not ask me or tell me to use a particular approximation. If I figure this out, I would get 78.53. It says, what's the area? As default, I would say the area is approximately equal to 78.5 square miles. 4 miles squared. Okay. Now that takes care of the first objective. Can you find the area of a circle? Now we're going to move on to what's called the sector of a circle. A sector of a circle is simply a region found by a central angle or a central angle, all right, and it's that part of the area. So it's kind of that shaded region. To find the area of a sector, and I want to label it as a sector. The area of the sector is going to be theta over 360. It's a fractional part of the area of a circle. So theta over 360 times pi r squared. This is the formula that I use to find the area of a sector. Area of a sector. All right, so in this particular problem, let's see. I know that I'm going to find the area of a sector. So I have the area equals. What fractional part is that? Well, its arc is 45, so the angle is 45. This is 45 over 360 times pi times the radius, 18 squared. Now, a graphing calculator can be a huge tool here, especially because they say leave my answer in terms of pi. So all I got to do is I got to figure out what the area of the sector is by crunching these numbers. So here we go. I'm going to grab my calculator, and let's see. I've got 45 out of 360. 45 divided by 360, which would be 1/8, or 0.125. I'm going to multiply that times 18 squared, and I get 40.5, all right? And I could write the area as 40.5 pi yards squared, or I could have written it in a fractional form by changing this 40.5. Remember, math, enter. That'd be 81 over 2 pi yards squared. I believe this is an acceptable way to put it in Math Excel. You need to double check yourself there. All right, in the next problem, they give me the diameter. In the area of a circle or the area of a sector, I don't need the diameter. I need the radius. I know the radius is half the diameter. Now, for this particular arc, the sector right here that they want, I know that the other angle is 120. Therefore, this angle would have to be 60. Those two angles have to be supplementary because the line going through the center is the diameter. All right? So to find the area of the sector, I'm going to take the fractional part, which would be 60 out of 360, times pi, times the radius, 13 squared. All right? So the area here, the area of the sector, I'm going to let my calculator help me here. I'm going to go 60 divided by 360. Get that decimal approximation, and then I'm going to multiply that times 13 squared. All right, and that gives me, some decimal here. I'm going to change that, math, enter, into 169 over 6 pi meters squared. So let's say you don't have a graphing calculator. No problem. I got to adjust this 60 over 360 to 1/6, and the 13 squared to 169 over 1. 1/6 times 169 over 1 is 169 over 6. Still get the same answer. All right, take a look at the next one here. I know that the area of a sector is theta over 360. Now this theta would be 270 because all together there in the center we've got 360. 270 over 360. They give us the radius here, so it's times pi times the radius squared, or 4 squared, or 16 you can put there as well. I know that the area of the sector, let's do this one by hand. So 270 out of 360, that would be 3/4 times 16 over 1, which would be 12. 3 times 16 is 48. 48 divided by 4 is 12. So this would be 12 pi square feet. All right. And one more here. If that is I see a couple of things. Diameter is 16. I want to make sure I'm using the radius. This angle right here is 45. Therefore, the other angle would be 360 minus 45, or that'll be 315 degrees. All right, so the area of the sector would be 315 out of 360 times pi times the radius 8 squared. All right, simplify. If you're doing it by hand, simplify the fraction. I'm going to cheat a little bit here. 315 divided by 360 equals times 8 squared equals, and that would be 56. So the area of the sector is 56 pi centimeters squared. All right. So far we've talked about the area of a circle. Now we split it and said, what about a fractional part of that? That's called the area of a sector. And the third thing that we have to do is find what is called the area of a segment of a circle. Now, if you look at this diagram that I have, in order to find the area of a segment, what we have to do is find the area of a sector and subtract from that the area of a triangle. Now, there's two ways to find the area of a triangle that we should be familiar with. One is base times height divided by 2. That's how you find the area of a triangle. All right? The problem is we're going to see some triangles here where we don't know the base and the height. In other words, there's not a right angle being formed anywhere inside the triangle to identify the height. Which brings us to another one that involves trig. And that is 1/2 times a side times a side times the sine of the included angle. Theta would be the included angle. This formula, applying trig, would actually be very helpful to us in some situations. I'm hopeful that I'm going to use the area of a triangle of base times height divided by 2. But if it doesn't work, I've got another formula now to fall back on. So let's take a look at this very first problem. All right, a couple of things that I know. I need to be able to find, and this is how I like to organize it. I have to find the area of the sector, and I'm going to subtract from that the area of the triangle. And that will give me the area of the segment. So let's start one at a time. How do you find the area of the sector? All right, so I know that the area of the sector is going to be a fractional part of the area of the circle. In this case, it would be 120 over 360 times pi times the radius squared. All right. I notice in the directions, it says round your answers to the nearest tenth. That's telling me I'm going to approximate pi, but I'm not going to worry about it yet. I'm going to subtract the area of the triangle. I look at this triangle and I say, oh, I don't know the height. The height would actually be right in there. I do have another formula, though, that I can find the area of this triangle. I can do it because I know that this 6 and this side over here has to also be 6. And the reason being is because all radii in a circle must be congruent. All right, so I could do this special formula that involves trig. And here we go. I've got 1/2 times the side of the triangle, 6, times the other side of the triangle, 6, times the sine of the included angle. So if that arc's 120, remember that angle is 120. And when I perform all this arithmetic, holy cow, it's a lot, yes, I know. But when I perform all this arithmetic, I end up with the area of a segment. Now, how I encourage you to do this is by using a calculator. Okay? In order to do this, though, I've got to understand that things need to be grouped together. I need to figure out all this and then subtract from it this whole piece as a group. All right, so let's see. I'm going to grab this calculator. Actually, no, let's start with the graphing calculator. So I've got 120 divided by 360. All right. Actually, I'm going to start that over. I want to do it like this. I'm going to go parenthesis. All right, to start the left side. Now, I have a fraction, so I'm going to put that in parentheses, right? It's 120 over 360. So parenthesis, parenthesis, 120 divided by 360, close the parenthesis. I'm telling the calculator, do this division first. Times pi, and on the graphing calculator, that's second caret, times, what's next? 6 squared. So I'm going to type in 6 squared. And that's the first part. So I'm going to put a parenthesis there. Subtract from that. Now I'm ready for the second part. It's 1/2, which I'm going to type in as 0.5, times 6 times 6 times the sine of the included angle. Now I'm going to real quick check my mode. My mode is on degree, so I'm going to quit out of that. And I'm going to type in sine of, I believe it was, oh shoot, I put it in the wrong spot. Whoop. Let's see if I can delete that. There we go. Sorry, I got to move this cursor all the way back over to the right spot. You should have checked the mode before. All right, so here we go. I need the sine of 120 degrees. Sine of 120 degrees. Close that sine off. Close the second part of the subtraction off. Hit enter. Oh, great. What did I do? Let's take a look here. All right. And it's saying, oh, I know what it is. I need to go back to the beginning. When I hit that sign before, I forgot the original. Insert a parenthesis. All right, now this should work now. Let's hit enter. And I get 22.1. So the area of a segment is approximately 22.1 centimeters squared. So you can tell I even messed up a little bit there. All right, it's going to take a little bit of practice here. Let's try to do the same thing on the other calculator. So if I go 120 divided by 360 times, now this calculator already did it for me, pi times 6 squared equals, and then I'm going to subtract from that, and I want it to do all this before it subtracts, so I'm going to put a parenthesis, 0.5 times 6 times 6 times the sine of 120, which on this calculator I need to go 120 sine, close it off, equals, and I still get 22.1. This is going to take you guys some practice on the calculators. All right, so let's look at this second one. I know in order to find the area of a segment, I need to take the area of the sector and subtract from that the area of the triangle. Okay. In this problem, I know it has a radius of 8. So I can find the area of the sector. This is 90 degrees out of 360 times pi times the radius squared. And that should give me the area of the sector. I'm going to subtract from that the area of the triangle. Now, because this is a right angle here, I know that the area of a triangle is 1/2 times the base times the height. Well, I know the height also has to be 8 because both the base and the height are radii. All right, so this is a little bit easier for me. Let's see, the area of this segment will be, let's use this calculator. So I've got 90 divided by 360 times pi, where's pi? Times 8 squared minus, and remember you wanted to do all this secondary calculation here, so I'm going to put a parenthesis, 0.5 times 8 times 8. Base times height divided by 2. And that gives me 18.3 rounded to the nearest tenth square feet. Did I label that one right? Yeah. Square feet. All right. One more here, and then we'll call this lesson done. All right. So if they give me that this angle down here is 60, I know that this angle is 60 because vertical angles are congruent. I see that they want me to find the area of a segment. So the area of a segment is the area of the sector minus the area of the triangle. All right. I notice there's no right angles in the triangle, so I'm going to have to rely on that trig formula for the area. All right. What do I know? I know the radius is 6. All right. So here we go. Area of the sector. 60 out of 360 times pi times the radius squared minus the area of the triangle, which would be 1/2 times a side, or the radius, times the other radius, times the sine of the included angle, which would be 60 degrees. All right? And again, remember, we have to do one piece and subtract the entire other piece from it. So here we go. All right, this seemed pretty easy. 60 divided by 360 times pi times 6 squared equals. I know that that gives me the area of the sector. I'm going to subtract from that the area of the triangle. And I put it in parentheses. 0.5 times 6 times 6 times the sine of 60 degrees. On this calculator, I have to type in 60 sine. Close off the parenthesis, equals, round to the nearest tenth, this would be an area of, 3.3. So the area of this segment would be 3.3 square meters. I hope this helps. Let me know if you guys have any questions.